Example 4, let h of x equal negative x squared and f of x equals x squared times cosine of 10 pi x and g of x equals x squared. So use the squeeze theorem to show that the limit as x approaches 0 of f of x is also equal to 0. So again, we're given the two functions, and we're assuming that h of x is less than or equal to f of x, which is less than or equal to g of x, right? So f of x is in between h of x and g of x. You can call it the squeeze theorem. You can call it the sandwich theorem too, because it's pretty much the same thing. So for pretty much, we just have to write our first statement, which is negative x squared less than or equal to x squared times cosine of 10 pi x. And then we know that's less than or equal to x squared. So therefore, we can assume, right, now that we know that, we can establish that the limit as x approaches 0 of the first function, negative x squared, is less than or equal to the middle function, the limit as x approaches 0 of x squared times 10 pi x. I'm sorry, I'm missing the cosine. Cosine of 10 pi x. And that's going to be less than or equal to the second function of g of x, which is the limit as x approaches 0 of positive x squared. All right. And then now that we know that, we can pretty much establish the following. We know that the limit as x approaches 0 on the first side right here of negative x squared. If we do direct substitution, we know it goes straight to 0, right? The vertex is right there. If we do the same thing, so it's less than or equal to, right, and less than or equal to, the limit is of x approaching 0 of x squared will be also the same thing, would be 0. Since it's both in the same place, right? And if we do substitute 0 in here, we get 0 times cosine of 10 pi x, 10 pi times 0, which should be 0 times 1. So there's still 0, right? So it also meets the condition where all these three are equal at that point. So that's also equal to 0. So therefore, we can say that the limit as x approaches 0 of x squared times cosine of 10 pi x, is also equal to 0. Now I'm going to let you guys try this. Try sketching it on your TI graphing calculator, and then just keep it for your notes, and then you'll see how the different functions try to squeeze in between those two right there, right? Make sure you guys follow the same settings, and you'll be set.